Love it or hate it, MongoDB, it's useful, and you need to know how to connect to it from a Spring Boot app. And that's exactly what we're going to learn in this tutorial. So let's get right into it. To help us get started, I've created a Spring Boot project that you can download from GitHub, link in the description below. Once you're here, you simply need to clone this repository down to your local machine. Once you've cloned down the project and you have it locally, you simply need to open it up in your favorite IDE. I'm going to be using IntelliJ Community Edition for this tutorial. So to have a Spring Boot app that connects to MongoDB, we're going to need a running MongoDB instance. So to keep things easy, this is our project, and in our project, we have this Docker Compose file. In the Docker Compose file, we have everything that we need in order to run a instance of Mongo locally. All you have to do is go ahead and open up a terminal. This might look different if you're on a Windows machine. This is obviously Mac OS. Linux would look similar to this. And you would go docker-compose up, and this will start your MongoDB instance. Now, if you don't have Docker installed, now is a great time to do that. So I'll leave a link in the description below to the Docker installation instructions. All right, with everything started up fine, we now have a running MongoDB instance. Let's see what this project actually does for us. What we have here is a pretty typical 3-tier Spring Boot app for the management of a bookstore. That's the domain of both books and the authors that write them. At the persistence layer, we're going to be using Spring Data Mongo to deal with all of the low-level interactions with MongoDB. And then we'll use the repository pattern in our app in order to interact with MongoDB. Now, MongoDB is a NoSQL database, and that's different from the more traditional relational databases. Now, in the relational way of doing things, we have links between our records when they're related. But in the NoSQL way of doing things, we would just make copies of the data when things are related. That's not always strictly true, but stick with me here. And in the presentation layer, we have our controllers, and these controllers expose a REST API. And then we can then call that REST API to do things like create, update, delete both our authors and our books. It's all in here in our controller code. So Mongo represents its records or its documents as BSON, which is a lot like JSON. And those like documents, they're stored together in something called a collection, which is kind of like a table in the traditional database, but not really. As MongoDB is a NoSQL database, it's completely normal in order to store a nested author in a book object or a nested book in an author object, for example. But duplicating all this data does have the drawback of needing to do updates in multiple places. And this could be okay for what you're doing, but I'm going to do something a little bit different here. We're going to store all of our authors in one collection, and we're going to store all of our books in a different, separate collection. And we'll know which book relates to which author because inside of our book object, we're going to store the author's ID, which naturally is the ID of the author in the author's collection. So in our domain, we have a couple of classes which represent the objects that we're going to want to store in the Mongo database. So we have the author here, which naturally represents our author. We've got the ID, which is going to be a string. We then have the given name, which in this case will be Jane as an example, the family name, Austin, again, another string, have a short description of the author, which again is just a string. And then we have the created local date time here and the last updated local date time. So that's just going to be two timestamps essentially that we're going to store in the database alongside this record to know when it was created and last updated. Now let's take a look at our book. So if we go over here, we can see that the unique identifier is the ISBN. We then have a title of the book, which might be Pride and Prejudice, for example. We then have the date published. So this is just the date, not a local date time, but just a local date. We then have the author ID stored as an attribute on this object here. So it's going to be the ID of the author in the author's collection. That's how we're going to link them together. And then we've got exactly the same as we did on author, a created time and then a last updated time. So these are local date times. They have both the date and the time. And that's the two objects which will represent our domain. Now you might have noticed that these classes are actually kind of nice and clean. And the reason for that is because we don't have any boilerplate code in here. We're having it all generated for us by Project Lombok. You can see these annotations up here, data, all R's constructor, no R's constructor and builder. These are all Lombok and it's exactly the same on the author side as well. For more information on Lombok, I'm going to leave a link in the description below for the free course that we have on Lombok as well. But the long and short of it is that this is going to generate all of the getters and setters, two string hash codes, the all args constructor, the no arguments constructor, and we've got the builder as well, which is generated with this builder annotation because I just think it looks cleaner in the code. Now you might be wondering, these look like fairly straightforward classes, and it's because they are. The only Mongo specific thing that we have to do in order to set these classes up to represent the documents that we're going to store in the MongoDB, in the Mongo database, is this annotation right here, @ID. We need to tell Spring Data Mongo which instance variable is going to represent the unique identifier of the document in Mongo. Naturally, it's going to be the ID instance variable on the author here, and on book, it's going to be the ISBN instance variable. And with all that done, we can now use Mongo in our application. And we're going to do that via the repository pattern. So if we take a look over in the repositories package here, we have 2 repositories, one for our author here and one for our book. You can see these look fairly similar to Spring Data JPA repositories, and that's because they are. The only difference is that we're extending the Mongo repository rather than the CRUD repository or JPA repository that you might see if you're using Spring Data JPA, which is used with the more traditional relational databases. Now, you might be wondering about these 2 things here. Well, this represents the object that we're storing inside of the database or retrieving. It's the object that the repository is concerned with. And this is the type of the ID, which is typically going to be a string if we're dealing with MongoDB. So MongoDB is useful and can offer you a whole lot of benefits over the more traditional approach. You know what else is like that? The Kotlin programming language. I'm working on a full course right now with the objective of teaching you how to write Spring Boot applications using the full power of the Kotlin programming language. And this is hands down my biggest project yet, and I am really excited to get it out there. As usual, I'm going to be releasing a ton of free content right here on YouTube. But this time I've listened to your feedback and I've created a bunch more premium content which builds on the free stuff. And the objective of the premium content is to take a working Kotlin and Spring Boot application, secure it using some pretty advanced Spring security, deploy it to the cloud, and then monitor it once it's there. So to know when this course drops and get an exclusive discount, be sure to sign up to the mailing list. There is a link in the description below. Okay, let's get back to it. So we've taken a look at our domain objects and we've taken a look at the repositories here. Let's now take a quick look at the service layer and the presentation layer before actually using this application and seeing it work with MongoDB. So we've got our 2 objects. We've got our author and our book. So let's head on over to the services package here, and we can see we've got the author services and the authored book service. More on that in a second. So let's take a look at the author service here. This is just a straightforward service. Well, this is the interface for it, doing things like listing the authors, for getting the author by the ID, for creating and updating an author and deleting an author. It's all of the things that the REST API is going to want to do, really. So if we now take a look at the implementation for this, we can see that we're using the author repository. So that's the Mongo repository that deals with the author for dealing with all of this. So we can see that it lists the authors. Well, we're just calling straight through to the repository there. Getting the author by ID. Well, we're just calling straight through to the repository. Creating and updating the author, that's a little bit more involved because what we're doing is we're receiving an object, which is the create update author request. And this simply is kind of a cut down version of the author object, which just contains the given name, family name, and description, which is only the stuff that we need to either create or update an author. Now, you might be asking, why can't we use the author object? And well, you can, but the author object has a bunch of extra stuff in there that we just don't need to use in this function. So we don't really need to know about the created date time and the updated date time. It actually causes more hassle to have to deal with those variables. So we might as well use a dedicated object here. So we pass that in. We'll then take a look in the author repository. We use this find by ID. So if the author already exists, so if the author with the ID exists, then we get access to it here and we can go ahead and update it. So we essentially just replace everything with the create update author request, but we can see here we have maintained the created date time. So we'll keep that from the existing author, the one that's in the database, but we will update the last updated date time to be now. Now that's if the author already exists in the database. If it doesn't, we can scroll down here and we can see that we're just creating a brand new one. So we'll use the ID, we'll use all of the information from our create update author request, and we'll set the created and last updated date time to be now. So simply the date and time right now, and then we'll create that author in the database, and then we'll just return it here. So we'll save it using the author repository. We do that on both, and then we simply just return it. Delete author, we're just passing through to the repository. So nothing special happening there. That is the author service. Now we do also have an authored book service. So the authored book service, a little bit different. I have decided that I want to return books with nested author information in there. Because if it's a REST API, I want to list all of the books, but I also want to see the author that wrote those books. Design decision. So I've created this authored book service in order to do that for us, and it's going to demonstrate how we can combine multiple different objects from MongoDB and then return them via our REST API here. Everything here, again, looks similar to what we might want in a REST API. So list books returns a list of authored books. Get book by ISBN, the unique identifier, will return an authored book or return an optional empty if that book doesn't exist by the ISBN. Create update book, again, will create an updated book and then delete the book. So very, very similar to the author service here. You might be wondering, what is an authored book? Well, ISBN, title, date published, everything that's already on the standard book that we're storing in MongoDB. The only difference here is you can see that we have a full author object nested inside of that. And then we've got the created local date time and the last updated local date time. So you might be wondering, why bother storing things in separate collections if you're then going to just nest the author inside of this authored book object? Well, we are collecting from two separate collections. So if we wanted to update an author, for example, we update it in only one place, and that's in the author's collection. We can then pluck the author out of that collection, put it onto the book, and then return it. So rather than nest everything in MongoDB, so nest the author object inside of the book object in MongoDB, which would mean that we would need to update loads of different book objects if we ever did update that author object. We only update the author once, and then we can, of course, retrieve it from the collection, put it on the authored book object, and return it. And that's what the authored book is. So if we go back to the service and take a look at the implementation here, if we take a look here, we've got the book repository and the author repository. So we need access for both for the authored book service here. Listing all of the books, we're simply going to get all of the books. We're then going to get the IDs of the authors from those books. We're then going to look up those authors using the IDs that we've plucked out of the book objects there. And then we're going to combine our book and author objects before returning them as an authored book. Now, getting the book by the ISBN is very similar, but we're only going to do it for that one book that we get from the database using its ISBN there. And then we've got the create update book, and see that we check to see that the author exists before we create or update the book. And we've done that because we want every book to have an author, because that's how it works in the real world, right? Books just don't appear from nowhere, they have an author. So that's our check to make sure that that is the case and the author does exist. The author's ID that you provide when you create or update the book, that author exists. If it does, then we'll simply go ahead and do very similar to how we've done in the author's service there. We either update the book if it exists, or we create a brand new book and then we return it by building an authored book. Delete book is just a pass through. And there's some more information on the authored book there. So hopefully that sheds some more light on what an authored book is as opposed to a normal book. So if we go then up to our controllers here, we've got our authors controller there. You can see this simply just calls through to the author service listing books. Now, what our presentation layer does do is it deals with mapping, and that's what this mapper does. So we've decided to use DTOs. To go into detail what the DTO is in this tutorial is probably a little bit out of scope. We've chosen to use dedicated objects in our presentation layer and then separate those out from our business logic and our persistence layer. That's good because it then allows us to control all of the attributes that are returned from our presentation layer. For example, we might not want to return the created date time or the last updated date time. And in fact, we don't in this case because our DTOs don't have that information in them. But it also allows us to craft the requests and the responses that come from the presentation layer from our REST API without impacting how anything's saved in the database. So we have this concept of a mapper, which goes from, say, the author that we have saved in the database to the author DTO, which is the REST API, the presentation layer representation of that author. And we have the same for the book as well. And you can see here, we've got the same for the create update author request. So list, get the author by ID, create update the author, and then delete the author. And then on the authored books controller, we have our list books, get book by the ISBN, create update the book, and we have our delete book as well. So we've gone through our application from the ground up. We see how it all hangs together. We know we're using MongoDB. We know we have a REST API to interact with. Let's try it out and see how it all works. So to test our application, we're going to need to run our application. So we already have Mongo running. That's what we did earlier with our Docker Compose up. So if we now go over to the Mongo application class, so this is the one that's annotated with Spring Boot application. This is our entry point. You can see our main method here. We simply need to click this green triangle here and we'll click run, and this will run our application. Looking good. We are up and running on port 8080. So let's open up Postman, and that's what we're going to use to be the client for our application. Okay, so here we are in Postman. So if you want this Postman collection that I'm about to use, link in the description below, you can just download that. So this is the different things that we can do in our application here. We can list our authors. We can get our author by our ID. We can update the author. We can do the same for the books here. We can list books. We can get book by ISBN. We can create update book. We can also delete the two. So I'm going to add those as well for when you download the Postman collection so you can try it out, but we're not going to need them right now. What we're going to do first, well, we take a look at list authors. That's going to hit our application. We simply have no authors in the database. And let's do the same for books. So we'll go over here, /books, get request. And we have no books in the database either. What we're going to do? Well, we're going to create some. We know that in order to create a book in the database, an author already needs to exist. So we're going to go ahead and create our author first. So if we go over here, we know that our create update author request has 3 things on it: our given name, a family name, and our description. So we're going to use Jane Austen as an example here. So given name Jane, family name Austen, and then we've got the description of Jane Austen, who is an English novelist known for her wit, social commentary, etc., etc., etc. So we're going to do that put request to the author's URL with the ID of the author that we want to create. So this is just a random UUID that I've generated. If you're building out this application, you might have the backend provide this for you. But in this case, well, it's absolutely fine. So we're going to send this away, expecting Jane Austen to be created in the database here. Okay, great. So we've got our response, which looks absolutely fine, 200 okay. So in theory then, we should be able to list the authors and have Jane in the response. Perfect. So it looks like we've got Jane in our database there. This is Jane's ID. Okay, looking good. We now have Jane created in our MongoDB. So let's go over to our books here. So we now know that we've got an author. Of course, we don't have any books. So we need to create a book. So I have the JSON to create a book here. The create update book has 3 things: title, date published, and the author ID, which of course is the author ID for Jane. Pride and Prejudice was published 1813, January 28th. And this is the actual ISBN for it. So if we send this, we should expect Pride and Prejudice to be created in MongoDB. Looking good. Now, we can see here that when it's returned, we have this nested author object, which is Jane Austen. And we know that this is coming from our books collection inside of MongoDB, and this is coming from our authors collection inside of MongoDB, and it's being combined by our service layer, by our business logic. So what we should be able to do now is go over and list all of our books. Great, okay, yep, Pride and Prejudice, there's Jane Austen, and we should be able to get that same book via the ISBN here. Great, there's Pride and Prejudice. If we were to change that, for example, we get a 404 back. So it looks like everything's working absolutely fine. We have a MongoDB instance, we're connected to it. We're using Mongo Spring Data in order to do that. We've got our repositories that we're using by our service layer, and then we're doing a little bit of magic in our service layer to combine the concept of books and authors and then expose that to our presentation layer, to our controller code, which then allows us to do things like list all of our books and then get the authors back nested there. If we were to go ahead and update the author, for example, so let's say it's Jane Austen, but we are going to say Jane, why not? And then if we click send, we can see it's updated there. And then if we go and list all of the books, we can see that Jane is updated here. Now, if we stored our nested author object inside of our book object in MongoDB, we'd simply need to go through every single book object and update it. Because we've done that extra step in our service layer, we simply only need to update our author in one place there. Now, as a bit of a bonus, the eagle-eyed amongst you might have noticed that when we were running the Docker Compose here, that we had 2 things in there. So we go over to Docker Compose YAML, we can see we've got MongoDB instance. We also have Mongo Express, which is a user interface that we can use to take a look at what's happening inside of Mongo. Well, if we go to localhost 8081 in our browser here, we can see Mongo Express. Now we've got our bookstore database here, and inside of our bookstore database, we have our author collection and our book collection. If we take a look inside, we can see examples of how everything is stored inside of the database here. So we've got a given name, family name, description, created, last updated, and then we've got the class representation inside of our application. And that's our author. If we then go take a look at the book collection here, we can see that we've got Pride and Prejudice, date published, author ID, created, last updated, and class. So everything's linked by the author ID there. And you can take a look through this and create objects and update them at your leisure and see how it all works inside of the database by using Mongo Express. So with Spring Data Mongo, some things are the same as Spring Data JPA, but some things are quite different. So I highly recommend taking a look at Spring Data JPA in more detail by taking a look at the Spring Boot for Beginners course right here. We really do a deep dive on Spring Data JPA, so it will help your understanding of Spring Data JPA, and by extension, Spring Data Mongo as well. So I'll see you over there.